All right, today we're doing 10.1 polygons and quadrilaterals. Your vocab: polygon, regular polygon, convex polygon, concave polygons, and then what a diagonal of a polygon is. Let's go right to these examples that are on your notes. All right, here they give us examples of polygons. Here they give us regular polygons, and then these are not polygons. Who can tell me the difference for the examples they gave you? What's the difference between the polygons and the regular polygons? Matt?
Regular polygons have all equal sides.
Yes, these all have equal sides, congruent sides, and also what?
Equal measures.
Of the,
Angles.
yep, all their angles have to be equal as well. That makes these all regular. These, however, different sizes on the sides and different degrees for their angles. So that makes them polygons, but not regular polygons. Over here, this one cannot be a polygon because of what? Right, and in our definition it says you can't have any intersections, all right? They have we have four segments coming in on one endpoint there. Here we can't have any what? No curves. All polygons have to be made up of what? Or what else do we call straight lines? Line, segments. Good. And what's wrong with this one? It's not closed. You cannot leave it open. Different names. Pentagon is a 5-sided polygon. Hexagon is a 6. Heptagon 7. Octagon 8. Nonagon 9. Decagon 10. But sometimes we don't know what it is, so say you have an 18-sided polygon, you go 18agon. You'll see this several times in math books and that sort of thing, so people know what they refer to, and that's okay. 15agon, 21agon, 18agon. Tell whether the figure is a polygon. If it is a polygon, classify it and tell whether it is a convex or is a concave polygon. If it's not a polygon, tell me why. So, is this letter A a polygon? Yes or no? Yes. Yes, it is. Because there's no curved lines, there's no intersections, it's closed. Is it a regular polygon? No, because the sides are definitely not all the same size. But now, is it convex or concave?
Convex.
Convex is what you would put, and this is why. This one is an example of convex. I want you to write below it and draw the example of a concave so you know the difference. So if you take this same figure, and I draw it so far like that, okay? See, I've got this bottom part, but instead of the top going up like this, if I had the polygon go down like this, that is a polygon. Not a regular polygon, but it is a polygon. So draw that figure also, that example. Yes, that is a polygon. That is a concave polygon. Because you can see that, see how this one side kind of caves in? That'll help you remember. See how it kind of caves in? Well, the trick being, if you look at two endpoints here, and if I do a diagonal, now if I went from here, whoops, that should be a straight line. If I went from here to here on my diagonal, everything's okay, it lies within here. But uh-oh, look at what happens if I go from this endpoint to this endpoint. I've got an endpoint on the inside. Can that happen? No, that makes it concave. How about B? Yes or no? No, why not? Okay, not all line segments. It has curves. You cannot have curves. All right, here we can classify. Any four-sided figure is a quadrilateral. So they'll say, classify that. It's a quadrilateral. If I had something like this, 1, 2, 1, 2, 3, 4. That is a quadrilateral. Could I give it any other name? No. That I cannot classify any further. That would be just a quadrilateral. However, there are other kinds of quadrilaterals. And the first one they have in your notes is a trapezoid. And the trapezoid is the only one of the quadrilaterals listed here. What's special about it? That
they aren't parallel.
ooh, so they only have
One pair of parallel sides.
see this little arrow? That means that tells me that these are parallel. And you guys with your parallel parking should know parallel pretty well, learning to drive. So the trapezoid is special where it only has one set of parallel lines. Now that's a trapezoid. A lot of people see the trapezoid more like this. Kind of like that little thing that they make the elephants stand on in the circus. One that still has one set of parallel lines. That's what makes the trapezoid special. Now all these other ones over here, they all have two sets of parallel lines. But what separates the parallelogram from the rectangle? Right. A rectangle, all the angles are right angles. They still have the two sets of parallel lines, but this one does not. The parallelogram does not have the right angles. It's kind of like standing straight. It's like pushing it and tilting it. Hey, I'm a rectangle. And I'm a parallelogram. Straight up, I'm a rectangle. And you're slanted, parallelogram. Same with the rhombus and the square. Square has the right angles. Straight up, you're a square. Slanted, I'm a rhombus.
I always said a rectangle was a parallelogram. I mean,
It is, technically. Not always, but sometimes. So let's classify this one. We have one set of parallel lines by the little arrows indicated here. Is it a quadrilateral?
Yeah.
Yes. Can I classify it further? Okay, so what kind of a quadrilateral will we name this? That would be your trapezoid. Right? Because that is the only one of the quadrilaterals that only has one set. How about this one? Rhombus or parallelogram? Because they're slanted. What makes it a rhombus and not a parallelogram?
All the sides are equal length.
Right, 6, 6, 6, 6. So it's a slanted square, therefore it is a rhombus. All right, now this is exactly what we were doing with the triangles yesterday. We'd add up all the angles of a triangle and they would always, and they forever will be, equaling what? 180. If you do a diagonal of a quadrilateral, that turns it into how many triangles? 2. So you have 180 and 180, so a quadrilateral will and always will be how many degrees when you add up the interior angles? 360 degrees. Write that big so you don't forget it. Now we have 4 angles. We've got the x, we've got the x plus 5, we've got the 125, and then we've got, well, what's that?
90.
Good, a right angle. So you can label that one 90 degrees. Let's find all the measures. Well, it's easy. We've got 2 so far. We've got 90 and we've got the 125. Let's find out what these other 2 are. So in any order, doesn't matter. Let's add them up. Looks like the boxes want us to put the x here. X plus what? X plus 5 plus 125 plus 90. Combine like terms. How many x's do I have?
2.
I have 2x. Oops, let's put that over here. 2x plus, what's 5? 125 and 90. 220. Subtract 220. Now I have 2x equals what? 140. Divide by 2, x equals 70, and the label? Degrees. Now we can name our other two. We've got 90, 125. This x is, we just solved it, 70 degrees. What is this one then? 75, because 70 plus the 5, this one is 75 degrees. Add it all together, they equal 360. Right, a couple more classifying. Is this a polygon, yes or no?
Yes.
Yes. We could even give this another one. 1, 2, 3, 4, 5. How many sides? What would we call that? If we wanted to, we could say it's a pentagon. And convex or concave? That would be convex, exactly. Nothing caves in. If this were pointing down in there and that was gone, then it would be concave. How about here? Yes or no?
No.
No? Why? Can't have curves. Or not all line segments on the figure.